Good morning, students. So today start with the topic two thin lenses in contact. So in the last class we derived the relation, that is lens formula, that is 1 by V minus 1 by U, that is equals to 1 by F. By using this relation we are going to derive the two combination of two thin lenses which are in contact. So this one is important for 3 marks. So sometimes they ask this derivation for 5 marks also, right? So for that, considering two thin lenses of focal length f1 and another lens, so calling the first lens as lens A and second one as lens B, right? So the first lens has the focal length f1 and the second lens has the focal length f2, right? So next, so this is the principal axis, considering a point object O. So from here, the rays which are coming from that object, one is through principal axis and another one makes some angle, right? So after which incidence on this, it gets refracted. So this point we call image I1, and here we have image I2, right? As object distance always taken as u. So here virtual v1 and here v I. So this is the actual image form I. Right. So for first lens, the image which is formed by the first lens A, right? So the object here, in the absence of the second lens B, the image is formed at I1. That is at a distance of V1. In the absence of the first, that is second lens. That one is the second lens B. That is image formed by the lens A. Right? So from that we can write the relation. So by using the lens formula, we can write that one as, so image is formed here, that is I1. So the image distance should be V1, right? Minus the object distance is 1 by U, right? So that is equals to, the image is formed by the first lens A. That's why we have taken the focal length f1 of the first lens A, right? So we calling this equation 1, right? So next, the image I1 acts as a virtual object for the second lens B, right? So for the first lens, O is the object. For the second lens, I1 is the virtual object. Actually, it is the image of the object which is formed by the lens A. So this I1 acts as a virtual object for the lens B, right? So then if we write the relation, that is lens maker formula, the image formed by the second lens B. So this is for image formed by lens A. That is the first relation. So next one is image formed by the lens B, right? So here I is the virtual object and here I is the image, right? So which is formed by the second lens, that one is the B, right? So if we write the lens formula 1 by V, right? So this one is the image distance V minus 1 by U1. Actually we have the formula 1 by V minus 1 by U, where U is the object distance. So here we have the object distance is what? V1, right? So 1 by V minus 1 by V1, that is equals to 1 divided by F2. Calling this one as second equation. right? So f2 because the focal length of the lens of the second lens, that is B lens, right? So these two equations we written by using the lens formula, that is 1 by V minus 1 by U is equals to 1 by F, right? Now add equation 1 and 2, right? Now adding these two equations, right, we get, so in the LHS we have 1 by V1 minus 1 by U plus 1 by V minus 1 by V1. So in the LHS, if we add 1 by V1 minus 1 by U plus 1 by V minus 1 by V1, that is equals to 1 by F1 plus 1 by F2, right? So if we consider this combination AB of two lenses as a single lens, that means equivalent lens, right, like this. So here is the object and here is the image. So this lens is equivalent to that of the two thin lenses which are in contact. Then if we write the relation here, this is the object distance U and here we have the image distance V, right? So for that, if we write the relation 1 by V minus 1 by U, that is equals to 1 by F. So this one is the equivalent lens of the combination of these two lenses, right? So if we call this one as equation 3, right? So if you observe here, plus 1 by V1 minus 1 by V1, right? So the remaining we get 1 by V minus 1 by U, that is equals to 1 by F1 plus 1 by F2. From equation 3, so by using this relation, so in place of 1 by V minus 1 by U, we can write that one as 1 by F, right? So here we can write 1 by F, that is equals to 1 by F1 plus 1 by F2, right? So this is the final equation of two lenses which are in contact, that is two thin lenses which are in contact. 1 by F is equals to 1 by F1 plus 1 by F2. F1 and F2 are the focal length of the two lenses and F is the focal length of the equivalent combination of those two lenses, right? So as we know, power of the lens P is equals to the reciprocal of the focal length 1 by F. So this relation, if we write in terms of power, we can write 1 by F is equals to P. That one is equals to P1 plus P2. So if we have any number of the lenses which we are joined with these two lenses, then we can write 1 by F is equals to 1 by F1 plus 1 by F2 plus 1 by F3 and so on up to 1 by Fn, right? So this is about the two thin lenses which are in contact. So this relation is very important, right? So next topic. So the next topic is Prism Formula. So this one is also important for 5 marks derivation. Several times they ask the relation of the refractive index, that is the Prism formula, that is the refraction through the prism, right? So for that we consider one prism A, B, C, where A is the angle of prism, right? So where A is the angle of prism, right? So when a ray of light which is incident on the first surface, so here we have two refracting surface. So the first refracting surface is AB and the second refracting surface is AC, right? So this prism has the refractive index N, right? So if this one is the radar medium N1, then the refractive index of the prism becomes N2, right? So as the ray of light which is traveling from the radar medium to denser medium, then it bends towards the normal, right? So this one is the first refracting surface AB, after which falls onto this surface, then it gets refracted, right? So this becomes the refracted ray. So this refracted ray acts as the incident ray for the second refracting surface AC, right? So this, we call this one as P, Q, and here R, right? So PQ is the incident ray and QR is the refracted ray. So this refracted ray acts as the incident ray for the second refracting surface AC. So the QR is traveling from denser medium N2 to N1, hence it's bent away from the normal, right? So this gives the emergent ray, calling that one as S, right? So here PQ is the incident ray, QR is the refracted ray, and RS is the emergent ray. So this point Q is the point of incidence and R is also the point of incidence, right? So if we draw the normal at Q and R, so calling this one as point N, right? So the incident ray which makes an angle into the normal, so that angle we call as angle of incidence, right? The refracted ray which makes an angle into the normal, that we call as angle of refraction R1. So here also we have the angle of refraction, that is R2. The emergent ray which makes angle into the normal, so that angle we call as angle of emergence, that is E, right? So now if this prism is absent, then the incident ray PQ will follow the straight path like this, right? Then if we extend this emergent ray backwards, we get the angle, that angle is the angle of deviation, right? So delta is the angle of deviation, right? So now if we observe from quadrilateral AQNR, right? So from the quadrilateral AQN and R, so if I write here, so this is angle A, here it is AQN and R, right? So from this quadrilateral, here this one is the normal and here this is also the normal. Then angle Q is how much here? It is 90 degree. Then angle R is also 90 degree, right? So the sum of all the angles of the quadrilateral is equals to 360 degree, right? So where A is the angle of prism, plus here we have angle Q is 90 degree, plus here the angle QNR, we don't know that angle, right? Plus here the angle R we have how much? 90 degree, because here we have drawn the normal to the refracting surfaces AB and AC, right? So if we draw the normal means the angle Q and angle R is equals to 90 degree, right? So the sum of all these angles is equals to how much? 360 degree, right? So here from this A plus Q N R, that is equals to 90 plus 90, 180. If we shift that angles to the RHS, 360 minus 180, so we get angle 180 degree. So calling this one as equation 1. That is from the quadrilateral AQNR, right? Next, from QNR, right? So from triangle QNR, so if I draw here, right? So this is Q and here it is N and here we have R. So here we have R1, here we have R2, right? So sum of all the angles of the triangle is 180 degree. So from this triangle we can write R1 plus R2 plus QNR. Angle QNR is equals to 180 degree. Because sum of all the angles is equals to 180 degree. That is from the triangle, right? So calling that one as equation 2. Right? So if you observe equation 1 and equation 2 in the RHS, we have the same terms 180 degree and 180 degree. So we can easily equate in the LHS terms, right? So from equation 1 and 2, we can write A plus angle QNR, that is equals to R1 plus R2 plus angle QN, right? So in the LHS and RHS we have the same term angle QNR, we get cancelled, right? So from this we can write A is equals to R1 plus R2, calling this as equation 3, right? So next, deviation, delta is the total deviation, right? So we can write total deviation delta, that is equals to sum of the deviations which taken by the two refracting surface, that is AB and AC, right? So if we observe here, this one is the delta 1, which is the refracting, that is deviation from the surface, that is AB. That one is the delta 1 plus, and the second refracting surface is AC. Here we have the angle, that one is the deviation delta 2, right? So the total deviation delta is equals to delta 1 plus delta 2, right? So this deviation we have like this. This is deviation delta, right? Either we can say from the triangle here, if I write M, so M Q R, right? So sum of the exterior angle is equals to sum of the interior angles. So if we call this one as the deviation delta 1, that is total deviation is delta 1, that means I minus R1. So this deviation is I minus R1 and this deviation is E minus R2, right? So that is the deviation. So that can be written as delta is equals to sum of the opposite interior angles. That means delta is equals to, we can write delta is equals to I minus R1 plus E minus R2, right? So from this I plus E, from these two terms, if I take minus common, then it becomes R1 plus R2, right? So from equation 3 we have R1 plus R2 is what? A, right? So the deviation delta is equals to I plus E minus, we write this one as A. So this one we call as equation 4. right? So this is the total deviation which is produced by the incident ray. So by the prism, that is delta is equals to I plus E minus A. That we call as the equation 4, right? So equation 3 we have A is equals to R1 plus R2, right? So next, the important here is for angle of minimum deviation. So here we are going to derive the relation for minimum deviation, right? For angle of minimum deviation. That means delta m, we call delta is equals to minimum deviation, delta is equals to dm or delta m, right? So this has to achieve means the refracted ray QR must be parallel to BC, right? For the angle of minimum deviation, the refracted ray which is inside the prism, that is QR, which is parallel to the base of the prism BC, right? So this ray is parallel to the BC. Then only we get the angle of minimum deviation, that is dm, right? So when this happens, QR is equals to, that is QR is parallel to BC, then the angle of refraction R1 is equals to angle of refraction R2. That means this value R1 is equals to the value R2. So that can be taken P is equals to common value R. Right? Now if I substitute here for the equation 3, that is R1 is equals to R2 is equals to R, then A is equals to R plus R. Right? So we write R is equals to A divided by 2. This is from the equation 4. We write this one R is equals to A by 2 is the equation 4. Right? So when QR is parallel to BC, R1 is equals to R2, then that value will be taken as R. Similarly, the angle of incidence I is equals to angle of emergence. Right? So I is equals to E, so that one is taken as one angle, that is either I or E. Right? So now substitute here, we get delta is equals to I plus, in place of E we write I minus A. Right? So I plus I is 2I, that is 2I minus A. If we shift A to the LHS, then delta M, or we write this one as D, because we apply the condition here for minimum deviation. So dm plus A divided by 2, that is equals to I. Calling this equation as equation 5 and 6. Right? Now from Snell's law. So from Snell's law, sine of angle of incidence to sine of angle of refraction is equals to the constant, that is the refractive index n21. So here we get the value of I, that is dm plus A by 2, and also we get the value of R. Now if we substitute that one into the Snell's law, we get n21 is equals to sine of A plus dm divided by 2, 4 divided by sine of A by 2. Right? So this one is the Prism formula. Right? So this is the final derivation. That one is the Prism formula. Refractive index of the second medium with respect to the first medium is equals to sine of A plus D by 2 whole divided by sine of A by 2. Right? So this one is very important. This is for 5 marks. Right? So along with this we need to plot the graph, that is angle of incidence along x-axis and deviation along y-axis, right? So if you plot the graph means we get like this. So this is the condition, that is I is equals to, right? So this one is the graph, that one is the final conclusion, right? So this is the derivation of the Prism formula. So lengthy derivation, but very important derivation, right? So next. So this is all about the derivations which we discussed in this chapter, right? So the next topic is optical instrument. So from we don't have any derivation, but they ask for the ray diagrams or the formulas of the magnification of the telescope and microscope. That is when that is at the nearer distance and when at the farther distance. That is the object is at infinity. Next is optical instrument. So that first one is microscope. In the microscope we have two: simple microscope and compound microscope. So here I have written this one as simple microscope. So microscope is an instrument used to see the smaller size objects into magnifying images, right? So that one is the microscope. So here we have the simple microscope, right? So for simple microscope we have a ray diagram. So object is placed near the considering two rays here, right? Right. So if we produce or extend back the rays, so this one is object AB and A dash B dash is the image. So here we can write AB is the object and A dash B dash is the image. So the image is virtual and array. So the image formed by the microscope is virtual and array. Right? So once they asked this for 2 marks. Ray diagram for the simple microscope. So for that, this must be important, right? So next, magnification. In that we have two at least distance. So magnification at the least distance m is equals to 1 plus d divided by f, where d is the distance of least vision, where d is called distance of least vision, right? So in that second one, at farthest distance, that means at infinity, we have m is equals to d divided by f. Right? So this is the ray diagram, and here we have the two formulas for the magnification m right? So one is for the least distance and another one is for the farthest distance. That means the image is formed at infinity, right? So here the image is formed at the least distance of distinction, that is d, right? So for that we have the formula m is equals to 1 plus d by f, and at infinity we have m is equals to d by f, right? So this is for the simple microscope, and the second one is compound microscope. For the compound microscope, we have two lenses. So one is the small focal length, and another one we have the larger focal length. So the focal length which is near to the object, so that one we call as objective, right? The lens which is near to the object, that one we call as objective, and the lens which is near to eyepiece, so eye, that one we call as eyepiece. So the focal length of the objective we taken as FO, and the focal length of the eyepiece we taken as FE, right? So if we draw this one is the principal axis and the image, sorry, this one is the object AB, right? So from this object, two rays like this, right? So these are the refracted rays. Again, from here it gets refraction. So here we have I, right? Whichever is here we have. Right now, if we extend these refracted rays backwards, they will meet at a point. That point gives the image of that object, right? So if we extend back, right? So this is the point meeting of the two rays. So here we get the image, that is here we have B double dash A double dash. So here also we get one image, that is B dash A dash, right? So if we compare here, the object size is very less AB. So if you observe here the image size, that's why we are replacing the simple microscope to the compound microscope to get the maximum magnifying power. So hence we are using the two lenses. So one lens we call objective and another lens we call as eyepiece. So objective we call FO and eyepiece we have FE. Right? So this distance is FO, here this distance is FE. So here one more term will come, that is L, where L is the length of the tube, that is tube length, that is equals to FE minus F4. L is equals to FE minus F4, right? So if we write the magnification for the compound microscope, here we have magnification for MO, that is equals to 1 plus d by f o, right? So this one is the magnification for the objective lens, and we have the magnification of eyepiece, that is ME. So this is at nearer point, and same we have at infinity, we have MO is equals to d by FO. Next, M is equals to L by F. This is for F. Right? This is for F. This one is for F. L by F. So magnification, if we write M is equals to MO into ME. So at nearer point, M is equals to 1 plus D divided by FE into L by FO. So this is at nearer point, and that is at infinity we have M is equals to D divided by FE into L divided by FO, right? So where L is the length of the tube, that is equals to Fe minus Fo. So this one is the ray diagram, and these are the magnification formula, right? So these two we need to remember at nearer point and at infinity, right? Whether if we forget this also, we need to remember these 2 points, right? So this is about the microscope. We have simple and compound microscope, right? So next and the last is telescope. So in telescope also we are using the 2 lenses. So first one is larger one, and second one is smaller. So this one is the. So telescope is used to see the farther distance objects, right? So for farther distance object, the rays which are coming from that object is always parallel, right? So this one is objective. So object is at a further distance. So the focal length of the object is FO, and this one is eyepiece. So FE is always less than F2, right? So if we extend back these words, so the image is formed at infinity. there is one more image, that is B, B dash, B dash. This one is the image, right? So this one is the F4, and here we have F, right? So here one more term we get L is equals to, that is L is tube length of the, or length of the telescope. So where L is the length of the telescope, right? So L is equals to F4 plus F. So this total length is the length of the telescope, right? Now, if I write the magnification, that is equals to, where FO is the objective and FE is the eyepiece. So FO by F, we have only one formula. This F is equals to FO by F. So this one is the ray diagram. So here everywhere we need to mention the ray diagram, right? So the magnification of the telescope is M is equals to F4 by Fe. So one more telescope we have, that is reflecting telescope, or we call this one as Cassegrain telescope, right? So in this, here we are using, in this telescope we use the two lenses. One is objective lens and another one is eyepiece, right? So in reflecting telescope we are using the two mirrors, that is concave mirror, right? So this one is the first mirror, and here we have this one is eyepiece. So this one is the first mirror, or we call primary mirror, and here we have one. So this one we have secondary mirror, right? So when the rays which falls onto these reflecting surface, after reflecting, it again falls onto the second mirror, and after reflecting they meet at the eyepiece, right? So this one is the ray diagram for the reflecting telescope. So for both the cases we have the magnification M is equals to F4 by F, right? So these are the important about the optical instrument. So they ask for 2 marks. Either they ask for the ray diagrams or they may ask for the magnification factors, right? Next. So as I already said, the power of lens, that is equals to 1 by F. So from that they may ask for 1 marks. Either they may ask for the problem. If they given the focal length, then we need to find the power of the lens. That is, if they given 5 centimeter as the focal length of the lens, then the power of the lens is equals to 1 divided by 5 into 10 to the power minus 2, right? That is 0.2 into 10 to the power of 2. That means 20 diopter. So diopter is the unit of the lens, right? So some natural phenomena which we are observing in the atmosphere, right? So in that first one is sun appears little late, appears little early, and sunsets little late, right? So next, second one is during sunrise and sunset, sun appears oval in shape. So this one is the third phenomena, and fourth one, mirage. Next, fifth one is sky or sea appears blue in color. Next, sixth one is clouds appears white in color. Next one, during sunrise and sunset, sun appears reddish color. Right? So these are the seven natural phenomena which we are observing in our atmosphere. Right? So the reason for that is the starting three we have, that is sun appears little early and sunset after little late, and twinkling of stars during sunrise and sunset, sun appears oval in shape. Right? So these are all the phenomena that caused due to refraction. So all these three phenomena causes due to the refraction. So for 1 mark, in the last year they asked this question for 1 mark, that is in 2020, why sky appears blue in color, right? So for 1 mark, these are very important. So for mirage, it is refraction plus total internal reflection. So mirage is also a natural phenomena that is caused due to the refraction and total internal reflection. So next, sky appears blue in color, clouds appears white in color. So these are, and the last one is one more video, that is, so here these three cause due to, that is sky appears blue in color, clouds appears white in color during sunrise and sunset, sun appears reddish in color. So these are due to the scattering of light. So these are due to the scattering of light. So these three phenomena are due to the scattering of light, right? So and the last one is, we have one more, is formation of primary and secondary rainbow, right? So the formation of rainbow is due to dispersion, next refraction, and total internal reflection. Right? So these are the 8 natural phenomena. So in the last year, 2020, this question is asked for 1 mark. Why sky appears blue in color? So the reason is, that is due to scattering of light. Right? So you have to remember all these 8. So the formation of rainbow is due to the dispersion, that is splitting of the light into its constituent colors. That phenomenon we call as the dispersion, right? So along with the dispersion, we have refraction and total internal reflection, right? So this is about the chapter ray optics and optical instruments. So from this chapter, 9 marks. So every year they asked in the concept I, so for your syllabus that topic has been removed. So the chances of the asking question from this topic, that is some natural phenomena, they explain why sky appears blue in color. For 2 marks, you have to write the theory of the scattering of light. That is by the ray scattering, right? So now we solve few problems. One problem which is in the regular class, that is in June 2019 they asked this problem. An object of 3 centimeter is placed 14 centimeter in front of a concave lens of focal length 21 centimeter. Find the position, nature and size of the image formed. Right? So this is the question which left. So other two related problems I saw it in the regular class only. So we will go through that videos. Right? So here they given the object of 3 centimeter which is placed to 14 centimeter in front of the concave lens. Here we have concave lens. So this one is the concave lens. This is the principal axis, right? So the object is at height of the object is how much? That is 3 centimeter, right? So this one is the object. So this is 3 centimeter. Next, it is placed at a distance of how much? That is 14 centimeter in front of the concave lens, and it has the focal length. If is here, then the focal length is 21 centimeter, right? So if I write here, the given height of the object HO, that is 3 centimeter, and they given the object distance U. So from the sign convention, the light which are emanating from left to right, we are measuring from the optic center O. That's why U be taken as minus, that is minus 14 centimeter. Similarly, the focal length F, that is equals to minus 21 centimeter, right? So from length formula, so here we need to find the image distance V, the nature and size of the image, that is V and height of the image. So these two we are going to find. For that we using from the length formula, that is 1 by V minus 1 by U, that is equals to 1 by F, right? So we need V, that is 1 by V minus 1 by U value is minus 14, that is equals to F value is minus 21, right? So minus into minus plus, if we shift to RHS, then it becomes 1 by V is equals to 1 by 14 minus 1 by 21, right? Either we can take LCM 14, 21, 7 2 so 7 3 right? 21 into 2, 42. So LCM becomes 42 here, then 14 means 3 minus 21, that is 2, right? 1 divided by 42. So V is equals to, so minus 14, right? So here we have minus, because minus into minus plus. So if we shift this one, again it becomes minus 1 by 14. So that is minus 3 minus 2, that becomes minus 5 by 42, right? So V is equals to minus 42 divided by 5. right? So 5 8s are 40, remaining is 2, so put the decimal means 20, so 5 4s are 20, that is 8.4 centimeter, right? So the image is formed. So minus represents, that is opposite to the direction of the incident ray, right? So minus 8.4 means somewhere here, right? So this is the image distance, right? Next, we need to find height of the image. So as we know, the magnification m is equals to, right? So magnification m is equals to v divided by u, right? So as v is how much? Minus 8.4 divided by u, we have minus 14, right? Minus 14. So m is equals to minus get cancels, right? So here it is 2 sevens are 14, 2 fours are 8, 2 twos are 4, right? 4.2. Next, 7 eights are 42. That means 0.8. M is equals to 0.8 centimeter. That means the height of the image which is formed is positive value, right? Sorry. Here we get the magnification 0.8, right? So from the magnification we need to find the height of the image, right? So we also know magnification, right here. Magnification m is equals to height of the image to the height of the object, right? So we need height of the image. So hi is equals to m into ho, right? So magnification is 0.8 into, so height of the object is how much? 3. So here it is 7 6 of 42, right? So 0.6 it is. So here we have 0.6, right? So 0.6 into 3, that is 1.8 centimeter. That is the height of the image. So here height of the image is positive, means the image is like this. So the size is almost very less, right? So if we observe here, we have 1.8, but the height of the object is 3 centimeter. So the image is here. They ask the nature. So image nature is virtual and error, right? So the size of the image is how much? That is 1.8 centimeter, and the nature of the image is virtual and it is error, right? So this is about the problem. This problem they asked for 5 marks in 2019. So similarly, 2 more problems they asked. So those problems I solved in already I solved in the regular class. So please go through the videos, right? Thank you.